Okay, I had a look at the question 11. I had to underline a couple of things as I was going through and having a look at this. So question 11d. Question 11d, I can see there's a bit of a trap for young players here. It says, calculate the maximum distance of the yo-yo from the holder's hand, but the equation gives the height above the ground. So effectively, if you think about this, your equation is doing this. So you've got x and y. You've got here, this is the start point of the yo-yo. Yo-yo goes down, turns around, and heads back up. Now, the yo-yo is giving the formula, the equation is giving the distance from the ground up to where the yo-yo is. What they're wanting is from the person's hand, how far has the yo-yo moved? So it's a bit of a different question. In fact, one's the opposite of the other, but we do know that's 100 centimeters. And that makes life very easy. So let's take a look, because we actually know, if we had the equation, here's the equation, S is equal to 56t squared. Having to read this off another page, sorry. That's why I keep having to slow down as I turn my head. Plus 100, there it is. Now, if we differentiate that, and we did before, we get the gradient function, which is also, by the way, the velocity equation. We know the velocity equation. The velocity equation was, 112 t minus 135. And of course, if we make that equal to 0, velocity equals 0, in other words, we're finding the turning point, we're finding this point here. Never forget what we're actually doing here, because if you differentiate that, you find the gradient function. If you make the gradient function, which this is, equal to 0, you find the time when we're at the turning point. Well, what is that? And fortunately, we went through and we did it, and we found that this was equal to, 112t minus 135, so t was equal to, 135 over 112. And therefore t was equal to, now it was 1.2 and a whole bunch of stuff. Now, it's very, very bad practice, generally speaking, to go ahead and to I suppose, round as you go. Always go back to the original. So the actual original was, I think I wrote it down here. What was it? Oh, yes, it was 1.205357 seconds. So it was, there was a few numbers in there. And I think it's probably quite good practice actually to use the entire equation each time. In fact, it's very bad practice not to. So what we want to do here is we want to place this number into this equation, and that will give us how high this thing is above the ground. And if we subtract it from 100, we then find out how high it is from the person's hand. So we get the opposite, if you like, simply by subtracting the answer from 100. So we know that when v equals 0, it's at the turning point. And when v equals 0, we know what t is. T is 1.205357 seconds. So I'm going to go ahead now. I'm going to enter that into the calculator, and I'm going to try and do this as best I can here, because it's got quite a lot of numbers to actually punch in. I'm very tempted to go 1.21, but just in the interests of showing how we probably should actually do it, I'm going to actually do the whole thing. 357. I think that's the number. Okay, so I'm just going to put that there. In fact, I'm actually going to stick that as in memory. No, I won't. No, I'll just keep it as the answer. So let's go ahead and do that then. So we're going to take the 56, and we're going to bung this in. And every time I see a t, I'm going to place that number in there. So here we go. We're going to go 56. 56 times brackets answer, and I'm going to square it. That's going to be minus 135. 135 times the answer, and then that's going to be plus 100, and we get 18.63839. So it's 18. So then this is S now. It's going to be 18 point, what have I got? 63839. 63839. Now, of course, that is in centimetres. And what we've found now is the different distance above the ground. We found this distance here. So to find the distance from the person's hand, we're going to subtract it from 100, and that will give us that distance there. Let's take a look at doing that now. So therefore, we'll put distance, so that's above ground, yeah, above the ground. I didn't write the formula in there, but you know what I did. I took the number and I placed it into the equation here. Okay, the number being this here. So I put this here, into this equation here, into this equation here, and I ended up with 18 point whatever. So I'll put distance, centimetres above the ground, distance from, I'll put operator's hand, the yo-yo operator, operator's hand, therefore equals 100 minus 18.63839. So let's see what that is. So I'm just going to go, there it is, go 100 minus answer, and it's going to be positive, which is going to be 81 point, and I'll keep it rounded to 2dps now, 18 point, sorry, what am I doing here? Sorry, 81.36, yeah? So it's going to be 80, what am I doing? It's crazy. 81.36, 81.36, and that's going to be centimetres from op's hand. Okay, and that's, and I'll put here 2dp. So that's how we calculate that. You can play around with that a bit, but that's how I would do it. You could change the equation actually and do it differently, but I think it's much better really to state the equation, use the 1.21 equivalent in the where for t, therefore you know that v equals 0 when t is that, and when that is true, when you substitute t into the equation, you find the distance is 18 above the ground. So the distance from the operator's hands must be 100 minus the distance above the ground, which is 81.36 centimetres from the operator's hand to 2dp. And that would be my answer.